Okay, I'm going to talk to you about, this is section 5.7 in your textbook. And this is what we started this week. We spent this week going over how to determine how many solutions, what types of solutions, and then actually by the end of the week actually finding all of the solutions to a polynomial function. And if you'll recall, back when we did quadratics, the solution was the actual physical place that we saw it cross the x-axis. And if it's a quadratic, that means it's x squared something, and so there's going to be two solutions. There were at times, though, sometimes where the quadratic did not even cross the x-axis at all. That didn't mean it didn't have two solutions, it just meant the two solutions were imaginary. And so we could still have imaginary solutions with polynomials as well. So when I graph a polynomial, maybe this is what it looks like, and I only see one solution where it crosses, but let me make sure my sound is on. Yeah. But that means there's other solutions that, because this is obviously a third degree function at least, it's an odd powered function, then there might be other solutions, but they might be imaginary. So that may or may not make sense right now. But my goal is to find all of the numbers that will plug this in and make this thing true, and all the locations where it crosses the x-axis if it's got real solutions. So what we're going to do is, first of all, we're going to try to find out how many positive solutions I might have, how many negative solutions I might have, and how many imaginary solutions I might have. And so the first thing we're going to do is we're just going to say, you're used to me saying if I ask you to find f of 3, you would just go plug in 3 anywhere where x was. Or if I ask you to find f of negative 5, you'd plug in negative 5 where x was. Well, all I'm going to write is f of positive, because all I want you to think about is, what if I ask you to plug in a positive number for x? So that, I don't care what positive number, and we're not going to actually evaluate it. I'm only interested in signs of each term. So if I took this, x to the 4th, and I put in any positive number, that means I would take that positive number and I would multiply it times itself 4 times. And my only question to you that I'm concerned about is, what sign would that answer have? So if I took a positive times a positive times a positive times a positive, I'm going to get a positive number. So I would bring down a positive sign, because for this term, when I plug in a positive number, I would get a positive answer. When I plug into the second term, and I have negative 18x squared, then I'm going to have negative 18, and I'm plugging in a positive number squared. Well, I would do this part first. So what is a positive number times a positive number? Well, I'm still going to get a positive number. But now I'm going to bring that down, and I'm going to now multiply it by a negative 18. So now a negative number times that positive number is now going to end up giving me a negative number for my answer for that term. We'll move on to the second part, and I've got 12 times a positive number. Well, a positive number is just simply a positive number. Times a positive 12 is still going to be a positive number. And the last one, it doesn't matter what x is, what kind of number I plug in, positive 80 is just going to be positive 80. So I know this seems kind of crazy at first, but there's my sign change signs for if I plug in a positive number. Well, now I'm going to go back and do the same thing. I'm just going to imagine for the time being, I don't care what number it is, I just now want to plug in any negative number. Well, if I have x to the 4th and I plug in any number and negative number and I take it to the 4th power, then that means I'm going to take that negative times negative times negative times negative. I'm going to take that negative number and multiply it times itself 4 times. Well, any negative number to the even power is going to be a positive, because a negative times a negative is a positive, and a negative times a negative is positive, and a positive times a positive, I'm going to get a positive. So even though I'm plugging in a negative number, once I raise it to the 4th power, it's still going to be a positive answer. Well, the next one, though, negative 18x squared, so negative 18, negative number raised to the 2nd. Well, a negative number to the 2nd is a negative times a negative, which is going to give me a positive, but now I'm going to take that positive and multiply it times the negative. I'm going to get a negative again. 12x, I'm going to multiply 12 times a negative number, 12 times a positive number, 12 times a negative is going to give me a negative. And then again, no matter what I'm plugging in for x, there is no x here, so that's going to still stay a positive. Now, I know that, just hang in there, it kind of seems crazy. Once I've done this, I don't care how many positives, how many negative signs I see. I'm going to be more interested in how many times does it change signs. So if this one starts out as a positive and it goes to negative, then yep, it changed signs. This one now is a negative and it goes to positive. Oops, it changed again. Now this one's a positive and it stays a positive. It doesn't change anymore. So it changed twice. So 2 is how many possible positive solutions I might have to this problem. But it's not just 2. It's either going to be 2 or any number 2 less than that until we get to 0. So if I go 2 less than that, that means I could also have 0 positive solutions. We did the same thing here, and we'll count sign changes. Changed once, didn't change here, up, changed again. So it also has 2 sign changes, and I have to count 2 less as well, and that could be 0 as well. So now what I'm going to do is start thinking about all the different combinations of positive, negative, and imaginary solutions I could have. If this is a 4th degree function, which it is, then I better get 4 solutions, period. I don't care if they're negative, positive, real, imaginary, but total I should have as many solutions as the degree of the function is. So I'm going to take 2, and I'm going to say, well, what if I have 2 positive solutions, and I can only take one number from each of these at a time. So I'm going to take 2 positives, and I could pair that with 2 negatives, or I could take 2 positives, sorry about that, and pair it with 0 negatives. Well, then I need to go account for what if I have 0 positives, and I could pair it with 2 negatives, or I could have 0 positives and pair it with 0 negatives. Now, I know I'm supposed to have 4 solutions every time, so what if I have 2 positive and 2 negative solutions, and that's already 4 solutions, then I wouldn't have to have any imaginary solutions. But this one, I've only got 2 positives, no negatives, so I've only got 2 solutions so far, so I must need 2 more imaginary to make up my 4 solutions. I have no positive, I have 2 negatives, I need 2 more imaginary to give me 4 total solutions. And this one I don't have any positive, any negative, therefore all 4 of my solutions must be imaginary. Now what these are possible scenarios of the types of solutions I'm going to have. It could be that when I finally do get around to solving this function, I've got 2 positive and 2 negative solutions. Or it could be that I have 2 positive and 2 imaginary. Or it could be that I end up having 2 negative and 2 imaginary. Or it could end up being that all 4 solutions are imaginary. It's going to be one of those scenarios. And we'll get on into that later. But for this purpose, all right now I want you to see is, can we figure out how many solutions and what type of solutions I could possibly have? So these are problems from page 363. This is number 5 on that page. So we're going to do the same thing again, and they're just asking us what are the possible types of solutions I might have. So the first thing I'm going to do is imagine, what if I plug in a positive number for x all the way through this function? Well, if I take any positive number and I raise it to the 3rd power, I'm going to have a positive times a positive times a positive, then I'm going to get a positive. So now I'm going to go to this term. I've got negative 2x squared. I'm going to take a positive number, and I take 2 positive and I raise it to the 2nd power. Then a positive times a positive is a positive. But now that positive is now going to get multiplied by negative 2, so that's going to now make it a negative number. Well, this is a positive number, and I'm going to multiply it by positive, so it stays positive. And then no x here, so just the sign comes down. Go back again, and this time I'm going to pretend that I'm plugging in a negative number. So, if I plug in a negative number and I raise it to the 3rd power, so I've got a negative, 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 my answer is simply going to be a negative. Negative 2x squared, so I'm going to plug in a negative. Well, a negative squared means negative times negative, which is a positive number, but that positive times this negative is going to make it negative. And then 2 times a negative number is going to give me a negative, and then bring down the negative. Hopefully this is starting to make sense. And there's some examples in your book too that you can go by, but hopefully I thought this might help if I could explain it. Alright, so now what I'm going to try to do is say, okay, I'm going to take what I know, and I'm going to figure out the sign changes. So, oops, I wasn't ready to do that yet. So I'm going to count. It changed signs. It went negative to positive, it changed again, so that's 2 times it changed signs, and now it went positive to negative, it changed 3 times. Alright, so the number of times it changed and decreased by 2, so that puts me at 1. Well, if I decrease by 2 again, which is what you want to keep doing, that's going to put me at a negative number of solutions, and I can't have a negative number of solutions, so I stop. This one actually changed signs no times, so I'm not going to have any possible negative solutions. So now it's just a matter of putting all of this into a chart to kind of keep it organized. The number of positive solutions I might have, the number of negative solutions I might have, and the number of imaginary I might have. So I'm going to say, okay, well, what if I have 3 positive solutions? I can't have 3 positive solutions and 1 at the same time, so I'm taking one number at a time. I could have 3 of these and 0 negative. That's one scenario. Or I could have 1 positive and it's paired with 0 negative. Well, I'm supposed to have 3 solutions total. Well, I already have 3 plus nothing is 3, so I wouldn't have any imaginary either. If I had any imaginary, it'd put me over the 3 number. Well, this one only have 1 solution so far, and I know I can't have any negative. I must need 2 more imaginary to make a total of 3. So one of these scenarios, when I get around to solving it, it's either going to have 3 positive solutions and no negative or imaginary, or I'm only going to have 1 positive and 2 imaginary solutions. So see if you can try number 6 right quick. You can pause it and see what you can do with that, and then come back and I'll show you the solution to it. Alright, so if I plug in a positive number to the 4th is a positive, but that positive number times positive 6 is a positive. A positive number times itself 3 times is still a positive, times another number that's positive is still a positive. A positive number squared is a positive, but that positive number squared is now going to get multiplied by this imaginary negative 1, and it's going to make it negative. Now this positive number, again, times a negative is going to give me a negative, and bring down the negative. Now when I plug in a negative to the 4th power is going to give me a positive. A negative times a negative times a negative times a negative is a positive number, times a positive 6 is a positive. A negative times itself 3 times, negative times negative times negative is a negative. That negative times positive 4 is a negative. Negative x squared, a negative number squared is going to give me a positive, but that positive times negative 1 is a negative. A negative number times a negative 5 is a positive, and bring down the minus. Count how many times it changes signs. No. Yes, it changed. No, no. So 1 sign change. If I go 2 less than that, it's going to put me in the negative, so that won't work. Sign change. No. Sign change. Sign change. So 3 and then 2 less each time. 2 less than 3 would put me at 1. So now set up your table. And so it's either going to be 1 positive with 3 negatives or 1 positive with 1 negative. I'm supposed to have 4 total solutions. 1 plus 3 is 4, so no imaginary. 1 plus 1 is only 2, so I need 2 more imaginary. And these are the possible scenarios of the types of solutions I'm going to have. I'm going to go ahead and put up the answers to 7 and 8, and so if you want to go ahead and try those and then just check to see if you got them. Alright, here's the answer to 7. So if you can check and see, pause it and see if you got the same thing I did. And here's the answer to 8. And then the next video I'm going to post is going to be on how to actually determine possible roots to a function. I hope this helps.